Hi, this is Miss Slitton, and this is my wonderful, wonderful, wonderful group of AP biologists here at lunch. Say hi. Hi. And we're going to discuss Chapter 2, AP Biology and its basic chemistry. I'm going to hit all the big points, okay? Make sure that you feel comfortable with them. I want to remind you, input and output studying. What is input studying? Oh, the silence is deafening. What can you do that's input studying?
Watching Bozeman.
Watching Bozeman is input studying. What's another example of input studying? Yes?
Reading textbook.
Reading the textbook. Good. What's another example? Yes?
Answering questions in the textbook.
Okay, now, not answering questions, though I do want you to do that. That would be an output, which is good. What else? There's something you've generated that you could maybe read over and study. What is that? Group shared notes. Yeah, look at your group shared notes. Look at the pictures. Look at the images. Look what's been highlighted. Did you take a picture of the terms you did and put it at the bottom of your group shared notes? That's a really good idea. Pick whoever has the best writing. You know, some of you write in font. Okay? Take a picture of it, those terms, and put them at the bottom of the group shared notes so you have all the terms to review. That would be a good idea too. Now, let's talk about output studying. What are some good examples of output studying? I heard one. Yes?
Writing a potential essay lecture.
Writing up potential essays. What else could you do? What one did you? Yes?
You can take practice tests.
Exactly. Where can you find practice tests?
Back of the book.
Okay, at the back of each chapter, right? And then you find the answers at the back of the book. Be very careful. Some of you look at a question and you go, oh, it's probably B or C, and then you flip to the back and you go, it's E. Oh yeah, I could see that. All right. Next question. It's A or D. Oh, it's A. Okay. You're not really knowing what you know and what you don't know. Commit to an answer. Actually get out a piece of paper or a Google Doc. Write your choices down. There's short answers. There's science practice applications. There are essay type questions. Answer them. Okay, and then once you've done that, go and grade it and look at your score. If you get 60%, then you know that's about how well you know it. And you should restudy those areas that you missed. Besides the back of the chapter, where else could you get more practice questions? Yes. Nice haircut. You look very handsome in a non-creepy teacher way. Okay. A Quizlet.
He's single.
Okay then. And where else besides Quizlet could you get practice questions? Yes. Online textbook. Exactly. Go and use that. Log into your online textbook and take advantage of it. Okay. Tell your person you're sitting next to, what are some ways you can step up your game when it comes to reviewing? What could you do?
We live in the same neighborhood.
All right. Very briefly, we talked about states of matter. Yes? What is this E right here next to these states of matter? Energy. Okay, so we'll come back to that in a little bit. We talked about important elements. Oh, hello. We talked about important elements we could find in our body, and we're going to remember that by what? Chinops. Okay, tell the person next to you what each letter stands for. Go. Okay, so now tell it to me. What does CHNOP stand for? Carbon, hydrogens, what's the N? Nitrogen, oxygen, phosphorus, and sulfur. Beautiful. We learned the atom story. Let's say it together. Ready? Be with me. Hands, hands. Did I not teach it to you? The atom story. Atoms are made of protons, neutrons, and electrons. The protons and the neutrons are in the nucleus, atomic mass. The electrons are in energy levels. 2, 8, 1832. 8, 8. 8 is great octet rule. Okay? Now, why do we want to know this information? This is what it boils down to. We want to understand the structure of an atom, because if we understand the structure of an atom, we could better understand how one atom interacts with another atom. to join, possibly to form molecules. If we understand that, we can understand subcellular structures, and we can understand how the cell itself functions in order to maintain what? Homeostasis, okay? So it all boils down to chemistry, which all boils down to physics, which all boils down to math, ultimately. We're just applying those concepts throughout. Okay, so when we look at something like this, we know a lot about how they might act. Okay, just by knowing this information, we know how it might act with another molecule. So when I look at lithium, what are some things I know about lithium right now that you could tell me? Describe lithium from this. Yes, tell me what.
It has an atomic mass of 7.
It has an atomic mass of 7. What does that mean when its atomic mass is 7? Tell me. Number of what? Protons and what? Neutrons. And that atomic mass is found where? In the nucleus. Good. Now, do I know how many protons and neutrons it has?
Yeah.
Yes, how do I know that?
The number below.
Number below. What's that number right there? Atomic number, and that is always equal to the number of what? Protons. So if my atomic number here is 3, then this number must be what? 4. Okay, and those protons and neutrons are located in the nucleus. What else do I know? Yes.
We know that it's more likely to lose an electron because we know that if it's a stable atom, it has 3 electrons. And so then
Okay,
two
wait, back up.
protons-
That's all awesome sauce right there, but just back it up just a little bit. First of all, you're telling me how many electrons I have. How many electrons do I have?
3.
3. I am assuming I have 3 electrons because I have 3 what? Protons. So I have 3 positive charges. I would have 3 negative. It was neutral. Now, put those electrons away from me, please.
Yeah, so we put 2 in the first energy, and then we have 1 in the next one.
Right, and how many can that next one hold?
8.
8. And I like exactly what you said. Is lithium happy?
No.
No. Why isn't lithium happy?
Because it doesn't have a full.
Doesn't have a full deck. That full deck would hold 8. What's the other way to get it happy? Octet rule. So what's the easiest way to make him happy? Yeah, he can get rid of that electron, but there's a consequence that comes with that. If he gets rid of his negative charge, he has a positive charge. If he has a positive charge, he will be attracted to things that have what? Negative charges. When we learn about cell membranes and nerves and setting up chemiosmotic gradients, that's going to become really important, okay? So that's why we're studying it now. Okay, good. Nice, nice. Let me get a question in here somewhere. Hopefully it's one that I have the right answer to. One of these has the wrong answer, and I always forget to change it. Let's go, Granny Smith. Screaming green. Yay! Hundy, are you proud? I'm not really that proud because if you didn't get it, I'd want to like throw something at you. Okay, but good. And good job. Oh, poop. Good job, Sunset Orange. You were first. Atomic Tangerine, Purple Mountains Match Seed. After you answer the question, put its electrons away. Once you answer the question, think how would you put the electrons away, and also discuss this with a neighbor. What's the difference between an ion and an isotope? Discuss with neighbors.
I know what an isotope is. I keep forgetting what an ion is.
Brick red, magic mint. Let's go, Razzmatazz. Brick red, commit. You can do it. Brick red. I'm tired of you. The charges aren't. Oh, darn it. What did somebody give us? A few of you maybe gave us. Not the number of electrons. What did you give me? Neutrons. Yeah. 17 and 18 together will make up the mass, right? Is that correct? And the atomic mass consists of protons and neutrons. Since I have 17 protons, I would have 18 neutrons. But I asked how many electrons. And if I have 17 positive charges, I have what? 17 negative charges. So let's put those away. How many in the first level? 2. And it can hold how many? 2. How many in the next level? 8. And it can hold how many? How many can the next level hold? How many? 18. 2, 8, 18, 32, right? So how many do I need to put in there? 7. Is he happy? No. What's an easy way to get happy? Get an electron. Either steal one or borrow, loan. Okay? In order to become stable. Okay? All right. Next, ion and isotope. What's the difference between an ion and an isotope? An ion has a what on it? Charge. Why does it have a charge? Gains or lose an electron. Whereas an isotope, you're varying the it has a charge because you gain or lose a what? Electron. I don't know what I said. Sorry. Whereas an isotope, you're varying the number of neutrons. The most common isotope is found where? On the periodic table. Okay? The most common isotope is found on the periodic table. The thing about isotopes is they can be unstable. That's why they can be used as medical tracers. That's why they can use their energy to irradiate something that you want to sterilize. We learned about the periodic table. We learned about periods and groups. Which one do you want to lay down with? Which one is the horizontal one? Period. We know our reasons. Okay? And when you look at groups, what does everybody in their group have in common? Same number of valence electrons. And if I know the number of valence electrons you have in your outermost shell, I know how you're going to what? React. Okay? If I know your number of valence electrons, I know how you're going to react because you're always trying to get happy, stable, right? So I know exactly what you're going to do. So it doesn't matter if you're hydrogen, lithium, sodium, or potassium, how many electrons do you have in your outermost shell? 1. If I jump over one group, I'm in beryllium, magnesium, and calcium, how many do I have? 2. Jump over again and again, and then this makes me wonder, what is it that periods have in common except being annoying? What does your period have in common? They're all in the what? Same energy level. They're all working out of the same energy level. Okay, ask your bio buddy, are you good? Are you in the Shadowlands or the Sunshine? Do you have clarifying questions?
Yes.
Yeah, I just want to add like first I'm gonna highlight like and something important.
Question? Okay, good. I'll make sure you got that. I was explaining. You don't get it. Yes. Oh, sorry. Angry. Do I smell 100? Or have some of you already failed me? Did you appeal? Brick Red, Mango Tango, Razzmatazz, let's go. And I'm done waiting for you, Brick Red. Oh my gosh. Okay, good job, Sienna. We've got some work to do. 90% of you got it right, though. I'm super proud of you. That's an A-. We could do better, though. We actually have already done this. How many electrons does chlorine have? How many electrons does chlorine have? 17. How many will go in the first level? 2. How many in the next? 8. Interesting. How many in the third level? 2 and 8 is 10. How many in the third level? 7. What did I ask you? How many in the second level? What's your answer? 8. Okay, if somebody said 18, what would be the question I would ask if that were the answer? How many what? How many neutrons, right? What's 12 an answer to? Nothing. What's 7 an answer to? How many in the third level? Ask your Bible buddy, show them your clicker. Chastisement or praisement? Okay, moving on. Come back to me. Come back to me. Now, those atoms that are not happy, that are not stable, will do something about it. And there are different kinds of bonds. The two we're focusing on right now are ionic and covalent. In order to form an ionic bond, first you have to become an ion. How does one become an ion? Gaining or losing electrons. When you gain or lose electrons, you have a charge on you. What do we know about opposites? Attract. Okay? Covalent bonds are about whatting? Sharing. Okay? You could share fair or you could share unfair. What's the fair share called? Nonpolar covalent. Can I predict who might share fair?
Yeah.
Yeah. Okay? Somebody who needs a lot, okay, like carbon, tends to share fair, right? He's not highly electronegative. He tends to share fair. And as a result, the kind of bonds he have, nonpolar covalent, riddle me this, would they be hydrophilic or hydrophobic molecules? When you have a nonpolar covalent bond, hydrophilic, hydrophobic. Think about that. Yeah, you don't know. All right. So when you share fair, do you have any charge on you at all, or any partial charges on you? No. Who does water like to be with? Things that have charges or partial charges. Why? Because it's a polar molecule. Oxygen anchors water. Oxygen and 2 hydrogens, highly electronegative. It's so close. It pulls on hydrogen's electrons. It shares with it, but it pulls on those electrons, so it makes the oxygen partially negative and the hydrogens partially positive. So water likes to be with molecules that are charged or polar because the water can align up to it, either the oxygen or the hydrogen. Okay? But if you're nonpolar covalent, you're sharing fair, are there any charges on you? No. So water doesn't mix well with you. That's why, what do we do to our Italian dressing? Shake it up. You have to shake it up because the oil and the water separate. This type of reaction, hydrophilic, hydrophobic, sets us up for cellular membranes, for barriers. So we can regulate what comes in and out of a cell. That's going to become really important then. Okay? So 2 different kinds of bonds, 2 different results, a relationship with water. And why do I even care about the relationship with water? Why is it even significant? Yes? A lot of water in our bodies. 70 to 90% of cells, living things, are water. So we care how those molecules interact with water. Okay, so then here, you should have no trouble answering this question. Caribbean green. Is C a true statement? Yes. Is it the best statement of your choices? No, because D is better because all of that is true. Okay? Check your bio buddy's clicker, chastisement or praisement. Question?
Phobia. Phobia. Is that like
Bravo Tango, razzmatazz on mellow yellow. Move it, commit. Okay, I'm tired. All right. Be with me. Good job, Sienna. Let's address the first issue. And this is a strategy for your questions, okay? Atoms of the same element that have the same number of protons but different numbers of neutrons. When we vary the neutron, what are we talking about? Isotopes. So we know the first blank is isotope. So who can we cross out? A and B. We're not even looking at them anymore. Because I know the first one, because all I know the definition of an isotope. So now I'm down to C and D. Okay? Then it says, well, molecules that share electrons is called a what kind of bond? Covalent is about sharing. That's how I chose D. Look at your bio buddy. Chastise or praise? All right. Now, here is water. We talked about properties of water, and it all boils down to water is a polar molecule. And because water is a polar molecule, oxygen shares electrons with hydrogen, but it doesn't share fair. Okay? Is this right here a polar covalent bond?
Yes. No. Yes. Yes.
This is a hydrogen bond. Okay? Now, that's the weak attraction between one molecule's partial negative and another molecule's partial positive. Where is the polar covalent bond? It's right here. Here's oxygen, here's hydrogen. This right here is the polar covalent bond. Right? Here's an oxygen, here's a hydrogen. That right there is the polar covalent bond. You with me on that? What's between these two is the hydrogen bond. When one water molecule hangs on to another water molecule, and you can overfill your glass so there's like a bubble of water over the top. When you have a meniscus in a graduated cylinder, okay, those are two different things I want to point out. The bubble on the top of the glass, what is causing that? Oh yeah, it will have surface tension, but why can I go over the rim of the glass and it doesn't fall down the side? What's holding that water together? What's that term? Cohesion. Cohesion. You know how you're going to remember that? Co-worker. We're together. Water to water. Cohesion. Okay? When you have water hanging on to the side of a graduated cylinder and it's creeping up there, that's not cohesion, that's adhesion. I'm sticking to it. I'm adhesive. I'm sticking to it. Cohesion, I'm together. Okay, you got that? Now, both those things come into play when you talk about water going up a tall, tall tree, right? Because the water molecules are hanging onto each other, not letting each other fall, being continuous due to what property? Cohesion. But they're traveling in a tube. What's the tube that they're traveling in? Xylem. And it's sticking to the xylem wall. That's called adhesion. When it evaporates out, the open stomata starts with a T. That's called transpiration. And there's also tension, but we haven't learned that yet. Okay? And when I look at this, all of these, one water molecule hanging on to another water molecule, what's that bond? Hydrogen bond. Gives you the properties of water. Why do I have a hydrogen bond here? Because I have a polar covalent bond right there. I have a polar covalent bond which pulls the electrons a little bit closer. You can't see that. You can't see that. Stop it. Which pulls the electrons a little bit closer and makes the oxygen partially negative and it makes the hydrogens partially positive. The polar covalent bond here is why you do ultimately have a hydrogen bond between another water molecule. Okay? And so we looked at those properties. We talked about water, how it can mediate the Earth's temperature by holding energy in those hydrogen bonds and re-radiating it out. How because it has a high heat capacity, our temperatures in our bodies don't fluctuate just like this, because we can hold that temperature and that energy in those hydrogen bonds. We talked about how it takes a lot of energy for that water to vaporize and kind of evaporate out into the air. But when it can hold all that energy, it can cool us as well. If we sweat, that water on us can hold that energy and take it out of our bodies. We talked about water being a good solvent. And it is a good solvent if you're what and what? Polar or charged or some, right? Some kind of ion. You are a good solvent. You're not a good solvent if you're nonpolar, right? Right? If you're nonpolar and you don't have any kind of charge, if there's no charge on you, there's nothing for the water to attach to. And most water in our body is called bound water because it's arranging itself in some sort of conformation. Whoever has the darkest shirt on that you're next to, kind of break yourselves up into groups of two. Whoever has the darkest shirt on, explain why is this water arranged differently around each of these molecules. Go. Okay, we already talked about this, water moving up a tall tree. We said don't belly flop, because that hurts. Be a diver and go in small splash. And last but not least, we talked about the importance of ice being less dense, so it, and then what? Saves good, or protects the life, insulates. You're like, what does this mean, Miss Lynn? I don't know. Insulates the life underneath, right? So it doesn't freeze solid. Okay, you're super smart. I love you. Have good, what's today? Wednesday. I'll see you tomorrow. I'll see you tomorrow. Be super smart. Make good choices.